Hi, we're going to look quickly at two models for the percolation assignment. One that uses DFS, depth first search. That's the recursive approach for trying to figure out whether there's percolation, that is, whether water flows from the top to the bottom. And the other is the union find method. First, we're going to look at a grid and see how it might work with the depth first search or recursive version. In this version, we open cells or grid spaces by choosing one at random. For example, we might choose 2, 4. And we can see here that in the percolation visualizer, that would make the cell whose row and column are 2, 4 white. And we can see that we've called open on 2, 4. If we open 3, 3, we get another cell that's open. The visualizer would show that it was white. Suppose that we open 0, 4. That's a little bit different because that cell's on the top row. And that means that it's going to be full because water will flow into it. And in the code you write and in the visualizer, any cell that's open in the top row becomes full, which means it will be blue. What happens then when we open 1, 4? Because 1, 4 has a full neighbor, we need to make recursive calls. And when you see the assignment write-up, it will indicate that you always make a recursive call if the cell you open is either full itself, which is only the case in the top row, or if it's got a full neighbor. Since 1, 4 has a full neighbor, we will make recursive calls. We'll call the DFS method, and we'll call up, down, left, and right. So 1, 4 will become blue, and its neighbor will become blue. That's a quick overview of how the depth first search or recursive version of percolation works. Now let's talk about the union find version. In union find, it's similar. We open a cell, and one difference in the percolation union find method is our grid stores booleans. That's only true false, or whether a grid cell is open. In the DFS version, the depth first search version, a grid cell stored an int, and the int could either be 0, which might mean blocked, or another value which might mean open, and another value that might be full. In PercolationUF, you determine whether something is open or full somewhat differently. Suppose we open 3, 3 now. Same thing we had before, we called open on that. What's a little bit different is what happens when you open cells that are going to be full or that have neighbors. Let's see what happens when we open 0, 4. That's going to be full. And the way that a full cell is marked as full in the union find method is it's placed in the same set. Remember that union find is also called the disjoint set problem. So 0, 4 is placed in the same set as VTop, the virtual top. So the diagram shows a virtual top, which is a cell not on the grid. And the assignment write-up says you should use a number that's not a valid index for a cell. So I'm going to union by connecting 4, which represents the cell 0, 4, and VTop, which is its own constant. Now, how do I know that 0, 4 corresponds to 4? Remember that the union find algorithm expects a single integer for every single element. Well, what happens is you hopefully will create a getIndex helper method that will take a row column index and convert it into a number. We can see here that 4 corresponds to 0, 4. So I've connected 4 with VTop. Let's see what happens when I open 1, 4. Now, 1, 4 is adjacent to open cells. Unlike in PercolationDFS, in the union find version, when you open a cell, you check its neighbors, and if one is open, you union them into the same group. So 1, 4 does not use any recursion in determining that it's adjacent to 0, 4, so I'm going to connect 9 with 4. I can see that by knowing that 1, 4 is 9 and 0, 4 is 4. Again, I'm using my getIndex helper method to do that. But 2, 4 is also open, so I'm going to connect 9 with 14. Remember, this isn't recursive. I opened 1, 4, which is 9, so I simply connect it to its open neighbors. That's 2 connects. Now I open 4, 3. That's a little bit different because it's a cell in the last row. And the last row has something that corresponds to VTop. We call it VBottom. The picture shows here that when I open a cell in the last row, I need to connect it or union it with V bottom. So 23, which is the number that corresponds to this cell, is connected with V bottom, and because it's adjacent to another open cell, I'm also going to connect 23 with 14. Remember that whenever you open a cell, you check its 4 neighbors and simply connect them when they're open. And if you open a cell in the bottom row, you connect it to V bottom, and a cell in the top row, you connect it to V top. How do we know when the system percolates? If V top and V bottom are connected, the system percolates. Have a great time.